Good morning, everyone. Welcome to the security seminar here at Purdue University. It's my pleasure to introduce today's speaker. Vitaly Shmatikov is an assistant professor in the Department of Computer Science at the University of Texas at Austin. Before joining UT, he worked as a computer scientist at SRI International. Vitaly's research focuses on tools and formal methods for automated analysis and verification of secure systems, as well as various aspects of anonymity and privacy. Vitaly received his PhD in 2000 from Stanford University with thesis on finite state analysis of security protocols. Here's Vitaly.
Hi. So, first of all, thanks for inviting me here. And the work I'm going to be talking about today is joined with Arvind Narayanan. This is, I've never talked about this before. This is actually the first time I'm talking about this subject. As a matter of fact, the work on which it's based has not been published yet. So we're still figuring out how to do some of the proofs. So this is, in some sense, this is work in progress. I'm pretty sure everything I'm telling you today is correct, but I hope you understand that you're first people in the world to see this. I've never talked about this before, so I decided I'll try it out on you. And the topic I'm going to be talking about is obfuscated databases. And here is, let me try to give you a motivation for what I want to do. So suppose you have a phone book or an email directory which contains some sensitive information. And you want to control how people access this phone book. So here we have a list of names, a list of phone numbers, a list of emails. And what you want is to give this phone book to people in such a way that it's easy to look up the number if you know the name. But if you don't know the name, the phone book does not reveal anything. Okay? So you can think of them. Okay, so one way to think about it, you can think of some sort of spam protection, anti-spam in online directories. You want to publish an email directory, so if you know the name of the person, it's very easy to look up the email. But if you just want to go and harvest the entire list of emails, there is no way of doing this. Okay? So this is a little bit of a weird notion, so I invite you to think a little bit, just on this simple example. They'll get a little bit more complicated later on, what it means. I'm saying that some forms of access should be easy and some should be hard, okay? So easy to look up the number if you know the name, but if you don't know the name, it does not reveal anything. Like you cannot go to this and get a list of names out of it. And you cannot get a list of emails. The only thing you can do, you can supply a name and get out the corresponding phone and email. So let me try to make what I just said a little bit more precise mathematically. And I'll do this on the next slide, but here it's a little bit more rigorous. That is, somehow I want to mutate the database so that it starts looking like a lookup oracle. That is, the database is like a function from names to phones. And what does it mean that it's like a function? I'll give a mathematical definition in a moment, but to be like a function, this means that the only query that is easy to compute on the transformed database or obfuscated database is something like this. So give me the phone where name is some name supplied by you. Because this, asking this question, this corresponds to evaluating this function. But nothing else is feasible. So if you don't know the name, you can't look up the phone. You cannot extract the list of phones. You cannot learn any names you don't already know. So, and this is interesting because now I'm saying I'm taking a database, and the database is just a table with information for the purposes of this talk. And you know, if you have a table, you can look at this column, or you could ask all sorts of complicated questions and access it in unlimited ways, and now I want to transform it, obfuscate it in a way that it becomes indistinguishable from a function, from names to phones. So this is like a fairly non-trivial task in general. So why do I want to do that? Well, the usual notion of privacy, and a very useful notion of privacy actually, and a lot of research has been done on this, is that I don't want you to have any access to my data. Maybe you can have some access to joint statistics, maybe you know some global parameters, but as far as my individual records are concerned, there shouldn't be any way for you to access them. And part of it is because if you get my individual record, I cannot really control how this data will be used once it's released. And this is a very good notion of privacy and a very useful one. Now, the notion I'm talking about is slightly different, and I'll give you some applications for which it's useful. And my notion of privacy here is that I'll actually give you the data, but I'll control how you can use the data I've given you. So this is a way of trying to retain control over the data after it has been released. And as you can see, it's a much more difficult problem. So it's very likely that a lot of things that you want to do, you just cannot do in this way. So somehow I want to scramble or obfuscate the data in the database so that when I give the database to you, I know exactly the ways in which you can access it and the ways in which you cannot access it. And applications of this are sharing data with untrusted parties. That's sort of common. Publish a database online, for example, or distribute it to other people, but prevent people from harvesting information indiscriminately. So my email directory example. You give an email directory to someone, and you want them to be able to look up the phone if they look up the email if they know the name, but they cannot abuse it by extracting the list of emails and send spam to everybody. Okay, so I hope you see the difference between this notion of privacy and what you might be used to as the notion of privacy. So here my goal is to mutate the database in such a way that when I give it to you, I control how you can access it. Okay? So here is sort of the big picture. So what do I mean that I control how you access it? Is that I want to say that certain questions, certain queries on this database are easy, and everything else is hard. Okay? Hard as in computationally infeasible. Now, this is a very strong requirement. Now, I am not saying that there's going to be a trusted third party that controls how you use the database I give you. I don't rely on any access control software. I don't rely on any ad hoc schemes for scrambling the data. I actually want a proof, a mathematical proof, that there is nothing you can do with the data I give you beyond what's allowed. Okay? And again, this is a strong requirement because having provable security is a much taller order, if you will, than having just security in some abstract sense, because I want to have a mathematical constructions based that has this property, that some questions you can ask, some questions you cannot ask. Okay, and of course we'll have to use cryptography to do that in some fashion. But I hope that you understand that I'm after something fairly ambitious here. That is. I'm not going to rely on any sort of trusted intermediary. I'll just assume that the data I give you is being evaluated or analyzed on completely untrusted platform. Basically, the adversary can do whatever he wants. And then I want to make things that I don't want him to do. I want to make them, well, I cannot make them impossible. At least I don't know how. But I'm just going to make them very, very hard. I'm going to make them infeasible. Yes?
So just to be clear, a query will either be answered easily or it's unanswerable. There is no issue of partially answering a query. Right?
I'll get to that in a moment. As a matter of fact, it's an excellent question, and I'll get to it in a bit. So hold that thought. It's a good thought. Okay, so what do we know about obfuscation in general? So what is the state of the art on this problem? So first of all, there are a lot of ad hoc obfuscation.